In this section, we're going to take a look at analyzing linear models. So a couple definitions we're going to work with. One, extrapolate. So when we extrapolate, that means we're estimating beyond the given points on of a graph when it makes sense to do that. So here there is a time and attendance graph. The attendance is listed in thousands, the time in minutes. And so we see that after 15 minutes, there's 5,000 people. After 30 minutes, after 15 minutes, there's about 2,500 people. After 5,000 people after 30 minutes. And then we hit, after an hour, there's about 10,000 people. And then I've extrapolated it out at 90 minutes. So after an hour and a half, we have 15,000 people that have arrived. So maybe this is like a concert or something like that. And people are showing up along the way. Now, this might make sense, 15,000 people. That's not an unrealistic number to fit into some stadiums. But depending on the size of a stadium or the event where it's taking place, it might not make sense to continue extrapolating. If you have a small venue that only holds 10,000 people, then it wouldn't make sense to extrapolate beyond the 60 minutes because we're full. So that's that part where it makes sense. If you can only fit 10,000 people, it doesn't make sense to get any bigger. If we are talking about some graph that's going down, maybe we're looking at the volume of a tank, so this is the volume, and this is the time, and over time it's going down. Well, would it make any sense to extrapolate beyond this point in time? Say this was after 5 hours. Would it make sense to extrapolate to 6 hours? No, we wouldn't. To have a negative volume doesn't make any sense. The volume's at 0, it's done. So we only extrapolate when extrapolation only works when it makes sense. So a little bit of practice with that. We have a local group is raising money for charity. They collect $250 a day on average. They currently have $3,750. Their goal is $5,000, and we want to represent this with a table, a graph, and an equation. So right now, they have $3,750. So that's right now. We're not on day 1. We're on day 0. And again, we've talked about this in the last section. We want to start at 0 for our initial value. So our initial value is 0. Our initial value needs to happen at 0. So this 3,750 is our initial value, and we start at day 0. We're collecting $250 on average. So every day here we should go up by $250. 4,000, 4,250, 4,500. So after day 3, they should be at 4,500. We can now plot these on the graph. So let's plot our points. I got a broken graph here. So we're starting here, 3,750, and we're going up by 250 each time. So there's our initial value. And then we got 4,000 after 1 day. We got 4,250 after 2 days, and then 4,500 after 3 days. So we plotted our points. We can connect our dots. And then we want to represent this with an equation as well. It's partial variation, so we'll use the y equals mx plus b format. And so y equals, and now our rate of change, we can get that from our information up above. It was the $250 a day. So 250x, remember the rate of change is always with the is always the number being multiplied. And then we'll add on our initial value of $3,750. Now, on the next page there, it says, when will they hit their $5,000 goal? Well, there's a couple ways of doing that. One, we can take our graph on here, and I'll use black to extend it. Maybe I'll just use pencil. It'll stand out differently. I'm going to extend my graph and extrapolate. And now graphing's not always the best because our lines might not line up perfectly. And you see here, I'm kind of above 5,000. But on this graph, it's matching at 5 days. So $5,000 after 5 days. So using the graph, we can extrapolate it that way. The other way is to use the formula we made. We could continue the table as well, but the easy ways are to use the graph or to use the formula. And since we have a formula here, 250x plus 3,750, we have y equals 250x plus 3,750. We want to know when it's going to hit 5,000. How many days is it going to take? So we're going to, that's our y value. The y values we're representing the dollars. 2,500 the day times the days plus 3,750. And now we haven't formally covered algebra, and we'll do that in a later unit. But as a general sense here, we can look for a value that we can fill in here. So we can do a couple of things. You can do trial and error here. Trial and error would work, especially with this small situation. We can try 2,500 times 4 plus 3,750. And so if we do this with trial and error, we would maybe take 2 attempts and get the 5 that we found earlier. With the algebraic method of doing this, what we want to do is undo all the steps along the way. And so this is a little bit of a preview of an upcoming unit. So we want to get the x by itself, and similar to our Pythagorean theorem solving, when we had to get the number squared by itself, we're adding 3,750 here, and we want to get rid of it. So let's get rid of it by subtracting it. But what if we subtract it from this side? We also have to keep everything equal and do an equal thing on the other side. So we'll subtract 3,750 from both sides. And so when we do that, we're going to get 5,000 minus 3,750 for 1,250. And then we'll have 250 times x here. Now, unlike the Pythagorean theorem, we're not taking the square root here because we don't have a squared, but we are multiplying x by 250. So how do you get rid of times 250? What's the opposite of that? Well, divide by 250. But if I divide that side by 250, I have to divide this side by 250 to keep it equal. 250 divided by 250 will leave me with 1x, or just x. And then 1,250 divided by 250 is going to leave me with 5. And that gives me my number of days. So similar to our Pythagorean theorem, when we solve this, we're just removing each part. And why did we do the addition before we did the multiplication? Basically, if you calculate something using bed mass, you evaluate using bed mass, then when we're trying to get rid of things, then we're going to reverse bed mass. And so we're getting rid of the addition and subtractions first, and then the multiplications and divisions next. So we're doing everything in a reverse bed mass kind of order. So you can do this with trial and error. You can do this with the table, continuing the table. You can do this with the graph, or you can try out the algebra when you're doing these types of questions. Okay, a couple more questions here. We want to describe the changes between the first and second, graph. So the first graph here, we are starting. We have a distance time graphs. We're starting at 200 meters, and we're moving up to 400 meters over 30 seconds. In the second graph, we are starting at maybe 50 meters, and we're moving to 500 meters in 30 seconds. So a general description of this would be that we've increased the rate of change and we've decreased the initial value. So from the first graph, the initial value has decreased, and the rate of change has increased. And we can state explicitly what those were. We could say that the initial value has decreased by, so we could add in there by 150. And then the rate of change is increased by, and now we'll just have to find a rate of change. The rate triangle here, 200 to 400. If we use this triangle here, maybe I'll draw that with a different color. So if we use this rate triangle here, we are increasing by 200, and we are so our rise is 200, our run is 30 seconds. And so 200 divided by 30 is going to give us, we want to write that separately, I guess, 6.67 approximately. And then on this one here, we're increasing from 50 up to 500. So that is an increase of, that's a rise of 450. And then our run again is 30. So 450 divided by 30 is going to give me 15. So the rate, and so that means we've increased our rate of change by 8.33 meters per second. So depending on what the situation calls for, we could add those values in, but in general, we could be just fine saying that we've increased the rate of change and decreased the initial value. So when we're analyzing our graphs, we're just looking at those, trying to determine when to extrapolate, when to do some descriptions and things like that. If it makes sense to extrapolate, which method are you going to use? Are you going to try the algebra? Are you going to try trial and error? Are you going to try to use the table of values or the graph?